This video focuses on parent functions. We will ask you down the road to memorize the parent functions, what the shapes are, and some of the important pieces like the intercepts and some critical points. This first slide, I'd say you don't need to write any of it down. We will go through them. These are just some of the forms. You'll notice that this is f of x, which is like the American way. And then this is more the IB way, where they have the f and then that semicolon x going to the arrow. The types that we're going to focus on parent functions, we just talked about the linear function, which is f of x equals ax plus b. Then there's the quadratic, those are your parabolas in that form. Then your cubics, those are what we call our, look like snakes. And then exponentials, and a curve up to the right, and logarithmic curve off to the right in a different direction. And then reciprocal. All right. Here are some key points for you to know. We do want you to find out some of these pieces, the intercepts, the turning points, which are our local maximum minimums, like where is the highest point or lowest point on the graph. Values for which the function doesn't exist, so those are like your domain restrictions. Any asymptotes that exist, those are those curves on the line the graph approaches. So here's our first parent function. The linear we've already focused on in this chapter. So we'll go into the parabola or the U-shaped. The parent function is y equals x squared. So I'm just going to plug in some points in for x to get out y. And then we'll identify the domain and range. So you're always going to substitute into your domain. There's your domain. And then what you get out is your range. So we say -4 squared, what is that? It's 16. So you put 16 here. Then substitute -3 in. -3 squared is 9. So you put 9 in here. And then you would just continue. -2 squared is, -2 times -2 is 4. And then -1 times -1 is 1. And then 0 times 0 is 0. And now notice when you go in the positive direction, they are the same numbers. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So we have some symmetry going on here. And I'm just going to graph these ordered pairs here. And I'm going to start with the critical point, 0, 0. So on the x-axis and y-axis, we go over 0, up 0. And then we would go over 1, up 1, and then left 1, up 1. So we just took care of those 2 points. And then we go over 2, up 4, and then left 2, up 4. And then our last pair is -3, 9 and +3, 9. So right 3, left 3, and notice they're both up 9 units. And now we connect the dots. And this is our parabola. It does have symmetry along that vertical y-axis. The domain is what numbers can you plug in for x. All numbers work for this parent function. But the range is what kind of numbers can you get out. Do you get any negative numbers out for y down here? No, nothing is happening here. So the range is y is greater than or equal to 0. What numbers are you getting out for y? The next parent function is a radical. Let's talk about that one. So your square root of x. So we just substitute some numbers in. And I'm going to start with the positive direction first. So I say the square root of 0 is 0. Square root of 1 is 1. Square root of 2 is about 1.4. Square root of 3 is about 1.7. I go one more. Square root of 4 is 2. Now a problem happens when we go in the negative direction. These numbers do not exist in a radical function because if you throw in -4 into your calculator, it does not exist. It'll make a message on there like error domain. That works more with our imaginary numbers, so we would replace it with an I. So these do not exist. So if we were to identify the domain and the range, the domain has to be x greater than or equal to 0. All right, so let's go ahead and graph some of these ordered pairs and we'll show you what the range will be. So first order pair is 0, 0. Then we have 1, 1, 2, 1.4, 3, 1.7, 4, 2. So the graph just kind of looks like this and goes off to the right. Now it's asking you for the range. What are the y values? So this is my x and this is my y. Is anything happening down here on the y-axis? No, nothing is happening down there. So we have to think that this graph, its range, has to be greater than or equal to 0. The next parent function is your absolute value function. Y equals the absolute value of x. So we're substituting numbers in for x. So let's start with the critical point, 0. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. Absolute value of 3 is 3. Remember, when you substitute a negative into an absolute value, it also ends up becoming a positive number. So you're going to get a 1, 2, and 3. So let's graph those ordered pairs. So we'll start with 0, 0, then 1, 1, 2, 2, 3, 3, then negative 1, 1, negative 2, 2, negative 3, 3. And we say this shape looks like a V. And we have our x and our y-axes. The domain, what type of numbers can you plug in for x? Any number works. Positive, negatives, numbers. So we say all real numbers work for its domain. But notice again, nothing's happening down here in the y negative direction. So we say y is greater than or equal to 0 on this parent function. Our next parent function is called a cubic. The shape looks like a snake. So we're substituting in some numbers in for x, so I'll start with 0. 0 raised to the third power, 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Let's go in the negative direction now. Negative 1 times negative 1 times negative 1 is negative 1. Negative 2 times negative 2 times negative 2 is negative 8. I should take care of those ordered pairs. So our critical point is 0, 0. And then we have the ordered pair 1, 1 and 2, 8. And then left 1, down 1. Left 2, down 8. So here is our snake. It rises on the right and falls on the left. Now let's talk about the domain and range. The domain, any number can work for the x values, what you can substitute in. So all real numbers work. Also, for the range, all numbers work for the range. We have positive and negative y values. So this is all real numbers too, for a cubic parent function.